I am going to teach you stream flow measurement. Stream flow or channel runoff is the volumetric rate of water moving through a natural channels like rivers and streams driven by gravity. It is a crucial component of the water cycle composed of surface runoff, groundwater base flow, and channel precipitation. Stream flow is the volume of water passing a specific point over time. Stream flow is measured in unit of discharge. Stream flow measurement techniques can be broadly classified into two categories, that is direct runoff and indirect runoff. Direct determination further classified into four: area velocity method, dilution techniques, electromagnetic methods, ultrasonic method. Indirect determination is further classified into two: hydraulic structures such as weaves, flumes, and hatted structures. Slope area method. First, calculation of discharge or flow rate in river or stream. We find how much water is there in the river or stream. The term flow rate or discharge describes the volume of water flowing per second in the stream. There are many direct and indirect methods of analyzing this discharge. One of the method is the area velocity method. Area velocity method contains two things: different velocity distributed in the stream, estimated the average velocity. Then second thing is estimate the area of cross section. Consider river. An irregular shape may have seen water flowing in the stream and saw that the water is moving at different speed across the width of the river. If you see the river, you will find the velocity in the middle is higher and less on the side. If plot all the velocities, get a velocity profile across the width. Velocity is higher at the top and decreases towards the bottom. However, velocity can be measured at all points along depth in moderately deep stream. Average velocity at 0.2 meter per second, that is 20% depth from top surface, and 0.8 meter per second, that is 80% of depth from the top surface, where 0.2 meter per second closer to the surface where velocity is influenced by surface stress. For shallow stream, it is sufficient to measure the velocity. Generally, mean velocity of flow at a particular section is obtained by keeping the meter at 0.6 depth. To measure the velocity at this point, the current meter is used. Current meter is one of the instruments in hydrometer to measure the velocity at a point in the flow cross section in the current meter. It consists essentially of the rotating wheel with a cone-shaped cup attached to it, which rotate due to the reaction of the stream current with an angular velocity proportional to the stream velocity. Cup get filled with water and turn wheel when placed in the flowing water. When the meter is lowered in water and when it faces the current of water in the channel, the wheel rotates. The rate of the rotation of the wheel depends on the velocity of flow. The number of rotation of the current meter cup wheel for various velocities are noted. Then we move on area velocity method. This method of discharge measurement consists essentially of measuring the area of cross section of the river at a selected section called gauging site and measuring the velocity of the flow through the cross section area. The gauging site must be selected with care to assure that the stage discharge curve is reasonably constant over a long period of about a few years. The stream should have a well-defined cross-section which does not change in various seasons. It should be easily accessible all through the year. The site should be in a straight, stable reach. The gauging site should be free from backwater effect in the channel. The select segment width, which is distance between two verticals. The select segment width, which is distance between two verticals. These are some general guidelines for selecting the segment width to minimize the error in measuring the discharge. Segment width should not be greater than 1 by 15 to 1 by 20 of the width of river. Distance in each segment should be greater than 10% of total discharge. The difference in velocity in the adjacent segments should not be greater than 20%. For this reason, the velocity verticals may not be equally spaced on these verticals. Only the current meter is placed at 0.6, 0.2, 0.8 depending on the depth of the stream. This is shown by the black dot. The figure shows the cross section of river in which n-1 verticals or the velocity averaged over the vertical at each section is known. Considering the total area to be divided into n-1 segments, the total discharge is calculated by the method of midsection. Discharge of Discharge of each section find out by multiplying its area with the representing velocity. Q is equal to area into velocity. Q is equal to summation of n minus 1 to I is equal to C1 into delta Qi. Delta Qi is equal to delta Q1 plus delta Q2 plus etc. plus delta Qn minus 1. Delta Qi is discharge in the ith segment. Delta Qi is equal to depth at the ith segment into off width to the left plus off width to the right into average velocity of the ith verticals. Therefore, delta Qi is equal to Yi into Wi divided by 2 plus Wi plus 1 divided by 2 into Vi. For I is equal to 2 to n minus 2, thank you.